Good day, guys. I'm expecting to see more people on the live stream. The live stream supposed should have started like 10 minutes ago, but I just had some technical issues and I had to share the link to all those who could not get it. Mm-mm. I'm going to check it. So I'm expecting more people to join the live stream. I'm hoping for more people to join the live stream. And we are going to have a full, complete 1 hour. I'm also going to share my whiteboard real quick. Just waiting for more people to join. Okay, now I can see there are two people on the live stream now. If you're on the live stream, you can just say hi to me in the chat box. You can just say hi and you can tell me your name. Or if you don't want to tell me your name, I'll just say hi to me in the comment section. I know that this live session is for students from grade 7 to 9, but everyone is welcome to this session. This session is like a self-help session for those who need answers to their assignments, their maths assignments, their science assignments. Okay, I see Uncle Sam. Good evening, Uncle Sam. I appreciate to see you on the live stream. I'm going to share my whiteboard very soon. I'm going to share my whiteboard now. I just want more people to join. So, and we'll start very soon. So I'm just going to start with a very simple topic. I know most of us will be familiar with this topic when I start it. So I'm just going to pick something random, and then as I see more students on the live stream. When I see more students on the live stream, I will do what their grade is looking for. So I can see like 2 or 3 more people has joined. If you are on the live stream and you can just say hi to me. From the beginning I already told anyone that is on the live stream, you can just say hi to me, so I could know who's on the live stream. And then I'm just going to start very soon. I'm going to start something very soon. Okay, so maybe I'm going to talk on. Let me talk on set. I know it's not it's not a topic that you see most of the time on YouTube. It's Set is a very interesting topic. It has to do with Venn diagrams. You know, there are different things that you can know from a set. So I'm going to share my whiteboard now. Let me share my whiteboard. I think I've talked enough without sharing the whiteboard. Let me share my whiteboard now. If you can see my whiteboard, you let me know. And also, I uploaded a video today on trigonometric identities, so you can check out that video. You see, I proved 3 trigonometric identities: sine squared theta plus cos squared theta equals to 1, and the other 2. So if you can see my whiteboard, you can let me know. Just let me know if you can see the whiteboard. I hope everybody should be able to see the whiteboard now. So if you can see the whiteboard, you can just let me know in the chat box, and then I will know that everybody can see the whiteboard. So I'm going to talk. Yes, okay. Uncle Sam said yes. Okay, so let me talk about set. I know Uncle Sam should be very familiar with set because this topic, they I think when we were back in school in Nigeria, they taught this topic either SS1 or SS2, and it's one topic that I see some students struggling with, especially when it has to do with Venn diagrams. And well, a set is a well. I just want to write the meaning of set. A set is a well-defined collection of objects called elements. You can call it elements or members. So and in set, when we want to write element, we write it like this. This is how we write element in set. Okay, we can say that we can say that um one is an element of A. Okay, so for example, let's say, and if you notice that when you're writing a collection of numbers or objects that belongs to a particular set, we always write it in a bracket, like a curly bracket, right? Like this. Okay. So for example, we can say that we can write out the set for A. A is equals to this are what is contained in the set of A. We have one, we have two, we have three, we have four. Okay, and it does not matter whatever order is written. Okay, if the same set A is written like this, four, two, one, three, they are still the same set. Okay, or even if this is B, okay, it's still the same set. Sorry, it's still the same set. Okay, as far as they have the same type of numbers in the set, like we can find one here in this set, you can find one here, you can find two here. It doesn't matter what order is written, it's still the same set. Okay, and for a set, you cannot repeat the same element. You can only write it one time. So now I say that E represents element. Okay, okay. And for example, we can say that 3 is an element of A, right? And there's another one that's written like this: E with a slash crossed across it. This means that not an element. Okay, so we can say that 7 is not an element of A because we cannot find 7 in the list of numbers written in between this curly bracket. Okay, this one is equal. We can write this one. This one means equal set. Okay, so if let me call this set B. Okay, so because set A and set B have the same type of collection of numbers in this curly bracket, we can say that set A is equals to set B. It doesn't matter the order in which the elements of this set are written. Okay, okay. Oh, sorry, I think it's making it smaller. Let me make it bigger. I don't know why it's making it smaller. Sorry, I'm trying to enlarge the screen. I'm trying to see where. Sorry, I don't know why it got smaller. Okay, let me just continue. I'll try to make it bigger. And another one is another a symbol like this is empty set. Okay, this is an empty set. Let me see if something can be written here. I want to go back to draw. I don't know why my pen immediately became smaller. So this is empty set. A set that has no element in between it is an empty set. Okay, and we can have something that is written like this: N and A. Okay, this symbolizes the number of elements. For example, we count it 1, 2, 3, 4. The number of elements in set A is 4. Okay, so and let's talk about the types of set. The types of set. Okay, and the first type of set I'm going to talk about is the empty or null set. Empty or null set. Okay, this is a set with no element. So it's the same thing as this one that I just wrote up here. So when A has no set, it's also symbolized as this empty or null set. The second type of set we have is finite set. Okay, finite set. This is a type of set, just like the term finite. Finite means that it has a limit, right? So finite is a set with a limited number of elements. So um, the next type of set is an infinite set. So infinite set does not have limit. It's always there's numerous numbers of elements in it. Okay, so you can just say that an element a set C is equals to 1, 2, 3, and we just keep going and going and going. It does not have an ending. The next set is equal set. Number 4 is equal set. Is equal set. Okay. So equal set for this is when two sets are equal to the same element. Just like I said, A and B they have the same. Okay. Number 5 is subset. Subset is this is when a smaller set belongs to a bigger set. Okay. So if we have A is equals to 1 and 5, okay, and we have B to be equals to 1, 3, 5, 7, 9. Okay, so A is a subset of B. That's it. I don't know what's going on with my cursor. Another thing I want to talk about is operations on set. Operations on set. First of all, we're going to talk about union. Operations on sets. And union means that all elements in either or both sets. Okay, and union is written like this. This is the symbol U. Okay, so if we have a set A which is 1, 2, and we have a set B which is 2 and 3, okay, if we want to write A union B, it will be equal to the combination of these two sets. That will be 1, 2, 3. Okay, that's the meaning of union. Now let's talk about intersection. Intersection. An intersection, the symbol for intersection is more like an N. It's not an N, but looks like an N. So this talks about the elements that are common to both sets. If we look at set A and B, set A and B, set A is 1 and 2, right? And set B is 2 and 3. So the only thing that is common between set A and B is 2. So that's A intersection B is equals to 2. Okay. So the next one I'm going to talk about is difference. It's difference in set. Difference. So this means that we can find an element in one set, but we cannot find it in the other one. That's what difference is. So this one is like it's minus, like a negative. Okay. So we have A to have element 1 and 2, right? And we have B to have element 2 and 3. So if we want to write A minus B, A difference of B, we can find 2. That means now we are trying to find we are trying to do the difference of A. So we can find there's a element that we can find in A that we cannot find in B, which is 1. So that's the meaning of difference in operations of set. Okay, and the next one is universal set. Universal set. Okay, in universal set, the universal set contains all elements being considered. The universal set contains all elements being considered. So, for example, if we can have we can have a set A to be 1 and 2. We can have a set B to be 2 and 3. We have set C to be 4 and 5, right? Okay, so the universal set will be 1, 2, 3, 4, 5, 6, 7, even more. It could be more. Okay. So the universal set contains all the set, all universal set contains all the elements in the different types of sets that we are given. So now I want to do some examples and I want us to follow. So let me do some examples. So for example, let A is equals to 1, 3, 5, and 7. Okay. And let B is equals to 3, 4, 5, 6. Okay. So now let's find A union B. Find A union B. That's the combination of A and B, but we'll make sure that for the ones that have the same element, we don't repeat. Okay. So A union B will be equals to 1, 3, 4, 5, 6, 7. That's A union B. Okay. So now let's find A intersection B. A intersection B. Okay, let's find A intersection B. The A intersection B is what is common to both. Okay, what is common to both? So 3 is common, right? And 5 is common to both of them. So A intersection B is 3 and 5. 3 and 5. Okay. Now let's do A, the difference of A and B. 3. Find A minus B. Okay. So if we do A minus B, that will be we are going to pick, we pick 1. It's only 1 because we are looking for element that can only be found in A and not B. So that's 1. That's 1 and 7. 1 and 7. Okay. And now let's find B minus A. So now in this case, when we are doing finding B minus A, we are finding element that can be found in B but cannot be found in A. So I will say 6, and I will say 4 and 6. So that's 4 and 6. Okay. So now let's assume we have another one. We have a unit. Let's say sorry, let me write. We have a universal set which is equals to 1, 2, 3, 4, 5, 6, 7, 8. Okay. And we have an element, a set A that contains 2, 2, 4, 6, 8. Okay. And now we are asked to find A prime. A prime can also be called complement of A. Okay. We are asked to find complement of A. Complement of A is what belongs to the universal set. These are elements that belong to the universal set but does not belong to set A. Okay. So it is like this: U minus A. That's this is the best way I can do this connotation. Okay. A prime is universal set, which is U minus A. So we are picking the element that is in the universal set that is not and that is not an element of A. Okay. So the A prime. Now we have A to be 2, 4, 6, and 8. So if we are doing the A prime will be 1. We cannot find 1 in A. We can't find 3 in A. So 3. We can't find 5 in A. So that's 5. We can't find 7 in A. So that's also A. The complement of A or A prime is 1, 3, 5, and 7. Okay. So now let's try and find, let's find A intersection A prime. Okay. So what I would what A intersection A prime, I told you that intersection is what is common to both sets, right? What is common to both sets. So now that is like we're doing A minus A prime. And I told you that A it has its own set, and A prime is the set that does not belong to A. Okay, so definitely we know that there's nothing that's going to be common between A and complement of A or A prime, right? So we can say that A, therefore A intersection A prime is equals to an empty set. Okay, because it's not possible to find anything that is common to both of them. So now let's find A union A prime. Let's find A union A prime. Okay, and we are given that the union is 1, 2, 3, 4, 5, 6, 7, and 8, right? So if we are doing A union A prime, that's the set that is in A combining together with the set that is in A prime. So if we are doing that, that is still going to be the same thing as everything that is in the universal set. Okay, yeah. So A union A prime is equals to the universal set. Okay, because this is the combination of elements that are in A and complement of A. Okay, so I'm going to do some word problems. I'm going to do some word problems, and I hope that the people that are here will be able to understand. If you don't understand, just let me know. Write it to me in the chat box. I'll see it. Okay. So the first question I have, word. Let me put word problem. I know many people don't like word problems. That's why sometimes when I'm making some videos, I don't like to put word problems. So let's say I will put in an instance. In a class of students, in a class of students, 10 like math. Okay, 10 like math, and let's say 7 like English, 7 like English, and 5 like both. There's only 5 of them that like both. So how many like either math, yes, or English? Okay, so in this case we are looking for students who only like one out of these two subjects. So we are looking for the students who like only maths, and we're looking for the students who like only English. Okay, so let me do it. The number of students that like, we are going to use M to connote math, right? The number of students that like math is 10, sorry. The number of students that like English is 7, and the number of students that like both, n of the number of A intersection B, M intersection E, sorry. M intersection E is 5. Okay, M intersection. I can connote this in form of a Venn diagram, but we're not going to do the aspect where I want to teach Venn diagram. So we have the number of M intersection E to be 5, right? So now we are looking for we are looking for students who only like one of these two subjects, who only likes one of these two subjects. Okay, so we're looking for students who only like one of these two subjects. So therefore we'll say that the number of students that like maths, which is 10, plus this number of students that like English, which is 7. Okay, and then we'll subtract it from the students that like both of them. Okay, because we're only looking for students that like only one of these two subjects. So that will be 10 plus 7 minus 5. Okay, so 10 plus 7 is 17. 17 minus 5 is 12. So we can say that only 12 students like either maths or English. Okay. So before I go any further, I want to. I know I still have some word problems I want to discuss, but before I go any further, I want to talk about Venn diagrams. Okay, so I want to talk about the Venn diagrams for two sets, and I want to talk about Venn diagram for three sets too. Okay, let me talk about Venn diagrams. Let's talk about Venn diagrams. Okay, so now this is a Venn diagram, right? For two sets, we have A, we have B. Okay, the middle here is A intersection B. Okay, everything in this side is A union B. Okay, so but first of all, what I want to do, I want to draw the Venn diagram for A prime. A prime, which can also be called complement of A. So for complement of A, this is when the sets, this is talking about the sets that can be confound in other sets but not A. Okay, so now if I draw a Venn diagram, it contains two sets, A and B. We have A and B. This is A, this is B. Okay, so everything that is concerned except A. So now let me shade A prime in this Venn diagram. So this is what A prime stands for. Okay, this is A prime. So everything shaded, everything included except A, except the set that is in A. This is A prime. Okay, so now I want to do A prime intersection B. A prime intersection B. Let's do A prime intersection B. Okay, for two sets. So we're drawing for A prime intersection B. We have A, we have B. Okay, we have A, we have B. So let's shade only B. We shade only B. Okay. This is B. So this is how we will represent A prime intersection B. A prime intersection B. So now I want to do A prime union B. Let me draw it by the side here. A prime union B. Okay. Set A, set B. Okay. So we have set A, set B. A prime union B. So this is anything, any set that does not belongs to A combined with set B. Okay. So it's quite similar to only A prime. So when we draw it, it looks like this. Is quite is the almost as the same thing as A prime. Okay. So when you shade it, this is what it looks like. Okay, that's A prime union B. So let's talk about A prime. Complement of A union complement of B. Complement of A union complement of B. So we have set A and set B. So we have A prime union B prime. Okay, so this is anything that is not found in A and is not found in B. So this is what it looks like. We shade everything that's outside these two circles. Okay, there's nothing that is involved that is inside the circle. This is how you represent it. This is how you, so all this part I shaded this A prime union B prime. Okay, everything that is outside except A and B. Okay. So now let me talk about, let me even draw the A union B, because I drew it there, but I want to draw it in a neat way. So we have A union B. Okay. So we have A and B. So A union B is going to be like this. This is A union B. Okay. So let's do A union B prime. A union B prime. We have A, we have B. All right. So this is A union B prime. A union B prime is quite similar to A prime union B prime. Okay. So that's everything that is shaded, everything outside of these two circles, everything outside of these two circles. Okay. So it's be like this. So this is what it looks like. Okay. That's A union B prime. So now let's talk about A intersection B. A intersection B. Let's talk about A intersection B. We have A and B. A and B. So this is A intersection B. I already showed it up there. Okay. So now let's do A intersection B all prime. A intersection B all prime. So if we have to do A intersection B all prime, we have A, sorry. We have A and B. We have A and B, right? So we are doing A intersection B prime. So that is everything that is outside this small box. Everything outside this small box. This small box is not included. Okay, that's what this one means. So we're going to shade all this part, except where A and B intersect, where things are common between them. Okay, so we shade everything except this part. This part is opened. This is the plate that is opened. Okay, so now let's draw Venn diagrams for 3 sets. So we've done for 2 sets. Let's do for 3 sets. Okay, so if we do for 3 sets, let's do A intersection B intersection C. If anybody has any question, let them drop it in the chat box, because I didn't get any question in the chat box. That's why I'm putting this. That's why I'm doing all this. So if anybody has any question in the chat box, they should put it in the chat box, and then I will do it. I want to make this one a little bigger, because we are going to be drawing 3 sets inside, 3 circles. Okay. So we have 1, we have 2, we have 3. So if you want to draw A intersection B, this is A, this is B, this is C. This circle belongs to A. Okay. This circle here belongs to C. This circle here belongs to B. I know I'm supposed to be using a different color to connote everything, but you can see where I'm thickening the boundary lines of this circle. So those are the point I'm pointing to. So where everything is touching everything is this part. Okay. So this is A intersection B intersection C. This is where things are common between the 3 of them. Okay. So let's do A union B union C. A union B union C. So we are drawing A union B union C. This is A, B, sorry, this is A, B, C. So A, B, C. So we want to find A union B union C. So let's shade all this part of the circle. Okay. So let's shade all this part of the circle. So when we're shading it, okay. So this is A union B union C. Okay, A union B union C. The next one is A intersection B union C. A intersection B union C. Okay. So it's like this. A, B, C. So this is A, this is B, this is C. So A intersection B. This is this is where A and B intersect. This is what is common. Sorry. This is where things are common between them. A intersection B. Okay. And if we want to join C with it, it's this part too. This is all the part for C, right? So we're going to shade all the part for that belongs to C. Okay. These are all the part that belongs to C. So this is A intersection B union C. Okay. So now let's talk about A union B intersection C. A union B intersection C. Okay. So let me draw the three circles. We have sorry, let me draw this again. We have A, B, C. So this is A, this is B, this is C. Okay. So A union B intersection C will look like this. Let's shade this part. Oh boy. We shade this part, and this part. Okay. So this is A union B intersection C. Okay. So that's it for the three sets. I know there are still more things that we can denote or connote from these three sets. There are still more Venn diagrams that can be drawn from it. But I want to do some word problems that involve Venn diagrams on set. Okay. So now let me do a question that involves two sets. Okay. So example 1. Let A and B be two finite sets. Okay, let A and B be two finite sets such that n number of elements of A is equals to 20 and the number of elements of B is equals to 25. Okay, and the number of A union B is equals to 40, or any you want to call it. So let's find the number of A intersection B. Okay. So now, if I draw this set, so I have A, this is A, this is B. Okay. So the number of everything that is in these two sets, A union B, is 40. Number of A union B is 40. Okay, we are looking for this part. We don't know it. Let's represent it as x. The number of A is 20. The number of B is 25. Okay, and we are trying to find the number of. We are trying to find x. Okay, so the formula that we need to know is the number of A union B is the same thing, is equals to combination of number of A plus number of B minus number of A intersection B. Okay, so number of A union B is 40. Number of A is 20. Number of B is 25. Number of A intersection B, we don't know, that's x minus x. So we have 40 is equals to 20 plus 25 is 45 minus x, right? So we can take 45 to the other side of the equal sign. So that's 40 minus 45 is equals to negative x. 40 minus 45 minus 5 is equals to minus x. So they correlate to each other. X is equals to 5. And one thing we need to know is that there can never be negative in set. Okay, if we have gotten our answers to be -5, then we know that we made a mistake somewhere. Okay, so we are now, let's do another question. Okay, let's do another question, number 2. If n of A minus B is equals to 15, okay, and the number of A union B is equals to 62, okay, and the number of A intersection B is equals to, let's say, 30, right? It says then find the number of B. Let's find the number of B. So now we're going to use the same formula. So if we use the same formula, that will be number of A union B is equals to the number of A minus B plus number of A intersection B plus the number of B minus A. This is the formula we're supposed to use. Okay. So we know that the number of A union B is 62. The number of A minus B is 15. Plus the number of A intersection B is 30. Plus the number of B minus A is not known. So we don't know that one. Okay. So let's just put plus n into B minus A, right? So now let's do it. 62 is equals to 15 plus 30 is 45. So 62 minus 45 is equals to NB minus A. 62 minus 40 minus 65 minus 45 is 20. 20 minus 3 is 17. So the number of B minus A is 17. Okay. So now for us to get the number of B now, that will be, we are now going to add up A intersection B and B minus A. So now to get the number of B, therefore it will be equals to number of A intersection B. Let me take this to the other side. Number of A intersection B plus the number of B minus A. Okay. So that will be equals to number of A intersection B. A intersection B is 30, right? It's 30 plus the number of B minus A is 17. So we can say 30 plus 17 is 47. So therefore the number of B is 47. So that's the answer to that question. So I can see if there's anybody that have any question in the chat box, you have a question from your school assignment, you want me to explain something that is quite different, let me know. Make sure you holler at me. Okay, that's why this live that's why we are on here on this live stream. I didn't get any question, that's why I kept teaching. Okay, so now I'm going to give another example now. So number 3, I believe this is number 3 or number 4. So in a party of 50 people, 12, sorry, not 12, let me put 21 likes disco music. Sorry, I couldn't wipe that off. Likes disco music, sorry. Okay, in a party of 50 people, 20 likes disco music. Okay. 32 likes, or let me say 30 likes R&B. 30 likes R&B, and each person likes at least one of the 2 type of music. Okay, so how many likes both disco and R&B? Okay, so let's start. Solution. So let A equals to set of people that like disco. Let A is equals to set of people that likes disco. Okay, and let B is equals to set of people that likes R&B. Okay, so now we are given that the A union B, that's the number of people in the party is 50, right? So the number of our A union B will be 50. That's the total number of people. The number of A people that like disco is 21. Okay. Number of people that likes R&B, which is N equals N of B is equals to 30. Okay. So now what are we looking for? We are looking for A intersection B, the number of A, the amount of people that like both type of music. Okay. So now I'm going to draw a Venn diagram. To represent all this information I have here. So this side is A, this side is B. Okay. So the number of A is 21, right? B is 30. The number of A union B, we write on top of the Venn diagram, is 50. Okay. The intersection, what is common between A and B, A intersection B, let's represent it as X. Okay. Let's call it X so that we'll make it easier for us. Okay. And I already said that A union B is the combination of the number of A plus number of B minus number of what is common between A and B, which is A intersection B. Okay. So now we want to get A intersection B now. So our A union B is what? Our A union B is 50. Okay. And then 50, the number of A is 21. Number of B is 30. Number of A intersection B is X. So that's minus X. Okay. So that's 50 is equals to 30 plus 21 is 51 minus x. Okay, so that'll be 50 minus 51 is equals to negative x. 50 minus 51 is minus 1 is equals to negative x. So the the negative will cross each other, x is equals to 1. So therefore we can say that only one person likes both disco and R&B. Okay, only one person likes both disco and R&B. Okay, so now let me talk about one more type of set. One more example on two or on is a on a Venn diagram that contain two sets. Okay, so I believe this should be example 5. So there are 35 students in art class. Okay, and 57 students in dance class. Okay, find the number of students who are either in art class or in dance class. So first one, when two classes meet, let's look for when two classes meet at different hours. When two classes meet at different hours, okay, and 12 students are enrolled in both activities. So number 2, we'll talk about when two classes meet at the same hour. When two classes meet at the same hour. Okay. So let me solve this. So the solution, when two classes meet at different hour. Okay, so let's use A to represent the students in dance class. Okay, A represents students in dance class. A represents students in dance class. Okay. D represents art class. Let me say to represent students in art class. That will be much better. In art class. D represents students in dance class. Okay. So the number of students are in art class is 35. The number of students in dance class is 57. And the number of students in both arts and dance class is 12. It says 12 students are enrolled in both classes. Okay. So now we're going to look for when two classes meet at different hours. When two classes meet at different hours. So when two classes meet at different hours, we have the number of A union D. That's when two classes meet at different hours. That's A union D, which will be number of A plus number of D minus A intersection D. So minus number of A intersection D. Okay, so the number of A is 35 plus 57 minus 12. Okay, 35 plus 57, I believe that should be 92. Okay, minus 12, so that's 80. So that's 80 students meet at different hours. Okay, so now let's look for when the two classes meet at the same hour. So when two classes meet at the same hour, it's still going to be the same thing. Okay, so this is still going to be like number of A plus number. When two classes meet at the same hour, that will be number of A plus number of D. Okay, so that will be 35 plus 57. That will give us 92. That will be the answer for this one. Okay, that will be the answer for this one. So I believe I've talked about Venn diagrams a lot. I wanted to talk about the Venn diagram on three sets. If I want to talk about the Venn diagram of three sets, I'm just going to give one example. Let me just give one example. I'm going to give one example for Venn diagram of three sets. Let me just give one example on Venn diagram of three sets. Okay. Venn diagrams on three sets. I think I want to change my pen to red. It makes me look cool. I think I love the pen. The pen is very bright, very attractive. So number 6, it says in a school we have a total of 50 students. In a school we have a total of 50 students. Okay, 28 students like math, 25 like science. Okay, 20 like English, 12 likes math and science, 10 like math and English, 8 like science and English, 5 like all three subjects. Okay, so the first question says, how many students like only math? How many students like only math? B, how many like exactly two subjects? How many like exactly two subjects? How many like exactly two subjects? Okay, C, how many like none of the subjects? Okay, so let's write out all the parameters out before we start solving. Okay, so we have 28 students that like math. So number of students that like math is 28. Okay, the number of students that like science is 25. The number of students that like English is 20. The number of students that like math and science, let me move this away, is 12. The number that like math and English is 10. The number that like science and English is 8. The numbers that like math, science, and English is 5. Okay. And the numbers that like all the subject, that's the total number of students. That's M union S union E. Okay. That's 50. The total number of students is 50. Okay. So I want to draw the Venn diagram. Let me draw the Venn diagram. Let me draw the Venn diagram. Let's draw the Venn diagram. So that's M. I want to change the color so that I don't get confused. This is S, and I'm going to use one more color. So this is S. Let me go back to red. This is M. Okay. This is E. So we have M, S, and E. Okay. So let me use blue to write it again. I hope you guys don't get offended that I move now. So M is number of students for M is 28. Okay, Uncle Sam says he likes the red pen. Let me go back to the red pen. Okay, let me go back to the red pen. Okay, I'm just drawing the circles just to make it look very not too confusing because these are 3 different sets. So M is 28, and number of students that like science is 25. Okay, number of students that like English is 20. Number of students that like maths and science. This part belongs to the number of students that like maths and science. Because if you look at the boundary line between maths and science, which is this blue and this red boundary line, that is the number of students that only like maths and science. This is 12. Okay. The number of students that like only maths and English is the boundary line between this red pen and this brown boundary of the circle. Okay, this is maths and English. This is 10. This side is 10. Okay. So now the number that like only science and English, the boundary line is this brown and this blue. Science and English is 8. Okay. So for all 3, math, science, and English is 5. So this is it, 5. So I believe I've written everything here, and the combination of all the students, which is math, M union S union E. I always like to write on top of the Venn diagram is 50. It's 50. Okay. So now, first of all, we are asked to find. Let me see what we are asked to find. We have to find how many students like only maths. So, but first of all, we will note those who like exactly 2 subjects. Okay. And then we subtract it from those who like all 3 subjects. So that's what we are going to do first. So now, for those who like only maths and science, only maths and science. Now, I want us to do for all those who like only 2 subjects. For only maths and science, we can connote that as n number of M intersection S intersection E prime, because E is not involved. That's complement of E. So we are going to do it. We are going to subtract it with the people that like all 3 subjects. That's minus number of M intersection S intersection E. Okay. The number of M intersection S intersection E prime is I believe that's 12. That's it here. Just only maths and science. That's 12 minus maths. The people that like only all the 3 is 5. So that's 12 minus 5. That's 7. So now let's talk about only maths and English. Only maths and English. So only maths and English will be connoted as M intersection S intersection E. That's S prime, complement of S. S is not involved. Minus the number of the people that like all the 3 subjects. Okay, M intersection S intersection E. Okay, so M intersection S prime intersection E is 10. So that's 10 minus number of M intersection S intersection E is 5. 10 minus 5, that's 5. Okay, so now let's talk about people that like only science and English. Only science and English. So that will be number of M prime intersection S intersection E minus number of M intersection S intersection E. So that will be M prime intersection S intersection E is 8 minus 5 is going to be 3. So now the number of students who likes only 2 subjects, will now be the addition of all these 3. That will be equals to 7, this one, plus this one, plus this one. So that will be equals to 7 plus 5 plus 3. 7 plus 5 is 12. 12 plus 3 is 15. So the number of students who like only 2 subjects is 15. So now let's talk about the number of students who like only 1 subject. Number of students who like only 1 subject. Okay. So now for only maths, let's talk about only maths now. For the students that would like only maths, so that will be the number of M intersection complement of S intersection E prime. Okay, and we know that the number of students that like maths, if we look at our Venn diagram, is 28. So this is right here, 28. So that will be 28 is equals to 28 minus 7 plus 5 plus 5. Okay, so one of these 5 is the number of students that like all 3 subjects. Okay, and the number of students that like only maths and science is 7. So now we are going to be talking about we're only going to be talking about the sets or the ones that we have done that involve maths. So for maths and science is 7, right? For maths and English is 5. So maths and science is 7. Maths and English is 5. Number of students that like all 3 is 5. Okay, so that's where I got all my numbers from, so that for anybody that is confused. So that's 7 plus 5 is 12. 12 plus 5 is 17. So we have it to be 28 minus 17. That will give us 11. So now let's talk about the students that like only science. Only science now. So for only science, that will be the number of M intersection S intersection E prime. Okay. So and the number of students that like science is 25. Okay, that's 25 minus. Now let's look for the number of students that like maths and science is 7, right? Minus 7. Now the reason why we're talking about the reason why we're talking about maths and science, because we are looking for students that would like only science. So for those that like that maths, we are trying to eliminate them and take them out of it, so that we can know the students that only like maths and that like only science. Sorry. So now let's look for the number of students that like science and English. That's 3. That's this one here, science and English. Number of students that like science and English is 3. Okay, so that's plus 3. Then the number of students that like all 3 is 5. So 7 plus 3 is 10, plus 5 is 15. So that's 25 minus 15. 25 minus 15 will give us 10. Okay, so that is number of students that like only science. Okay, So now let's talk about only English. Only English. Let's talk about only English. Only English now. So for only English, that will be number of M prime intersection S prime intersection E. So in our Venn diagram, the student that like English is 20. This is right here, 20. Okay. So that's 20. So that's 20 minus the number of students that like English and math is 5. Okay, number of students that like English and math is 5. So that's 10 minus 5. That's English and math plus the number of students that like only science and English is 3. Okay, plus 3. Number of students that like all the 3 is 5. So that's 20 minus 5 plus 3 is 8. 8 plus 5 is 13. So 20 minus 13 is equals to 7. So now we can say that the number of students that like only one subject. So now we're going to calculate everything. Number of students that like only one subject, is equals to, oh, I see, I can see Sister Loretta. Thank you very much, ma. I appreciate you. Thank you for joining the live stream. So the number of students that like only one subject is 11 plus 10 plus 7. Okay, so that's 11 plus 10 plus 7. Okay, 11 plus 10 is 21. 21 plus 7 is 28. So these are the number of students that like only one subject. Okay, so now let's look for the number of students that don't like any of the subjects. Okay, because you'll be surprised that there are some students that don't even like that don't like any of the subjects. So how many students like none of the subjects? That's what we are looking for. How many students like none of the subject? How many students like none of the subjects? Okay, so that can be connoted as n, the number of M union S union E prime. Okay, so this is number of M union S. So this will be equals to the total, the number of the student, the total number of the student, which is N of M union S union E. Okay, minus everything inside the circle. Everything inside the circle. Okay, so the number of the total students is 50, which was given in the question. Everything inside the circle. So that will be this. Now we're going to add up the student that like only one the student that like only one subject and the student that like two subjects. Okay, so the number of students that like only two subjects is 15. Okay, 10 minus 15. The number of students that like only one subject is 28. Okay, so that will be equals to 50 minus 28. Okay, now plus 5 too, because the number of students that like all three subjects is 5, plus 5 too. Okay, so 15 plus 5. So this number of students that like only one subject. This number of students that like two subjects. This number of students that like all the three subjects. Okay, so that's 15 plus 5 is 20. 20 plus 28 is 48. So 50 minus 48 will give us 2. So it's only 2 students. Therefore, we can say only 2 students like none of the subjects. Only 2 students like none of the subjects. Okay. Yes. So we just have 5 minutes more for me to end the live stream. So I'm just quickly going to do something. I'm going to do something that's a little different. I'm going to do something that is a little different. I know that we have done I know we have done sets today. We did set on two, we do two we did Venn diagrams of 2 sets, we did Venn diagrams of 3 sets. So now I just want to do a quadratic formula. I want to solve a quadratic equation. Let me solve a quadratic equation before I leave. Before we call it a day. Okay. So, and I'm going to solve this quadratic formula in 2 ways. I will do it by factorization method, and I will do it by quadratic method. So let's do quadratic equation. The quadratic equation is s squared minus 5x. Should I use minus 5x? Let me use minus 7x. Minus 7x plus 10 is equals to 0. So I want us to solve. Let me scroll it up very well. So we are solving by factorization method and quadratic formula. In Nigeria, we call it almighty formula. Take formula. Okay. So by factorization method, we have x squared minus 7x plus 10. So now, first of all, we are going to look for two factors that if we multiply together, we'll get 10x squared. So the product is 10x squared. The sum is what is in between. So this is A, this is B, this is C. So the sum is minus 7x. And the factors is two numbers that we can multiply together to give us 10x squared, two numbers that we can sum up to give us minus 7x. So that will be minus 5x and minus 2x. Okay. So that will be x squared minus 5x minus 2x plus 10. So x squared divided by x is x. Minus 5x divided by x is minus 5. So minus 2 can divide x. Minus 2 can go in minus 2x and 10. So minus 2x divided by minus 2 is x. Plus 10 divided by minus 2 is minus 5. Okay. So we have x minus 2 equals to 0, or x minus 5 is equals to 0. So that's x is equals to 2 or 5. Okay. So this is the one. This is factorization method. So now let me do for almighty formula. We know that almighty formula or quadratic formula, whatever you want to call it, the formula is x is equals to minus b plus or minus root b squared minus 4ac all over 2a. Okay. We know that b is minus 7. So minus into minus 7 plus or minus b squared is minus 7 squared minus 4 times a is 1, c is 10. Okay. All over 2a. So that's 2 times 1. So x equals to minus 7 is 7 plus or minus 7 squared is 49 minus 4 times 1 is 4. 4 times 10 is 40 divided by 2. So x is equals to 7 plus or minus 49 minus 40 is 9, root 9 over 2. Okay. So x is equals to 7 plus or minus root 9. The square root of 9 is 3 divided by 2. So that's 7 plus 3 over 2, or 7 minus 3 over 2, right? So therefore, S is equal to 7 plus 3 over 2 is 10 over 2, or 4 over 2. So S is equals to 5 or 2. So that's the same thing we have here, 5 or 2. S is equals to 2 or 5. So let me steering. Let me go back to my screen. So I hope that you guys were able to learn one or two things. And for those who knows about set and quadratic formula, I hope that you guys were able to refresh your brain. I hope that you guys enjoyed the live stream. And I really appreciate everybody that came on the live stream. Big ups to everyone. Big ups to Uncle Sam. Big ups to Sister Loretta. I appreciate you guys for coming to join the live stream. And we're going to call it a day today. Thank you, everyone. I hope that you guys have a great rest of your day. Bye.